Okay, let's go ahead and get started. We're on 11-5, and we are going to actually get to the problems in 11-5, but I need you to go ahead and draw this triangle. You need to memorize sine, cosine, and tangent, and what they represent. So, Michael, what does sine represent?
Oh,
1 over what?
adjacent. No.
So,
Yeah, so it's opposite over.
opposite over hypotenuse. Good. Betsy, cosine.
Adjacent
Over hypotenuse. Good. And then Marissa, tangent.
Opposite over adjacent.
Opposite over adjacent. The quicker you guys get to that, opposite over adjacent tangent, opposite over hypotenuse sine, and adjacent over hypotenuse cosine, the easier these problems become now and in the future. And I'm telling you right now, guys, I'll just be honest, I was tutoring a geometry student, and they're at East Side. So if you're playing on East Side about this time of year, guess what they're going over?
Sohcahtoa.
Sohcahtoa. And I've taught this now in different ways. This is going to be the third way of teaching it. I'm not going to get into actually solving different parts of the triangle, but I need you to memorize Sohcahtoa. Like if you can memorize that, you should be okay. All right, so we talked a lot about the 90-degree angle, and we're done with that. But there are two acute angles in this right triangle. It's angle A and angle C, right? The two acute angles. And sine, cosine, and tangent are useful for those two angles. Let's start with angle A. Okay, what I want you to write here is write sine, which is the abbreviation S-I-N, of A. Sine of angle A. Okay, somebody told me that sine was opposite over hypotenuse. So, looking at angle A, which side is opposite of that? 15 is opposite of A. So I'm going to put that above here. 15 goes on the top. What is the hypotenuse of this triangle? 17.
Will you round it?
So here's what you do with your calculators. You put 15 divided by 17.
Do you really need a big one? Or no?
Well, what's your answer?
0.88.
Yeah, that's what I got.
Okay, it's approximately 0.8823. So I'm going to put 88.24. It wants you to round to the nearest 10,000. Where does it say that? It's in your homework. Round to the nearest 10,000. So you have to round to the fourth decimal place. Wasn't it 88235?
Yeah.
But that 5 makes the 3 go up 1, so it's 0.8824, approximately. Here's what the ratio means, guys. This is one of the points of why we even look at sine of A. Okay, if you had angle A, if you had that angle, then the side opposite and the hypotenuse, this is how they relate. Ready? Look at it, guys. Look up here. 15 is about 88% of what 17 is. Isn't that true? 15 is about 88% of 17. It's almost to 17, but not quite there, is it? True, false, yes, no? Yeah, this is a little bit smaller than that one, and that's for this ratio right here. Okay, let's do the second one. Cosine of A. Cosine of A. So what's cosine referring to? Wyatt. What's cosine? What over what? You don't even have to think of the numbers, just what? Adjacent over hypotenuse. So, Rachel, what is the side adjacent to A? 8. Why not 17? Because isn't that kind of next to it?
Hypotenuse.
Yeah, 17 is already the hypotenuse, so 8 is the adjacent side. And what is the hypotenuse? 17. So what's 8 divided by 17?
0.4706.
0.470. What was it originally?
758.
58. So that 8 made the 5 go up 1. So that's my estimation. Ready? What that means is this. This side is about 47% of that side. It's about, what's 47%? About 50%? Isn't 8 about 50% of 17? Where am I getting those percents of? Some of you are like, where am I getting those? Because I'm just throwing out a percent. Marissa?
If you look at the first two decimal places and to find a percent, you multiply it by 100, which is moving the decimal over two places.
Yeah, I'm just saying this 0.4706 is technically 47.06% or 88.24%. So that's where I'm getting these numbers. Ma'am?
I just forgot what I was gonna say. Never mind.
Are you sure?
Yeah.
Okay, all right, let's go with tangents. And tangents, Emma Grace, of A. What does tangent refer to? What two sides?
Opposite over adjacent.
Opposite, adjacent. Okay, so if I'm looking at A, what's opposite of A? 15. What's the adjacent of A? 8. What's that?
1.875.
And I think it's exact, 1.875. So you don't have to round that because it's there.
Wait, Mr. Wright, if we were looking at angle B, then we were looking at adjacent, we could choose 15 or 8, right? Because neither of them are the hypotenuse.
B?
Yeah.
Okay, that's why when we get the sine, cosine, tangent, we're not looking at the B. We're only looking at the two acute angles.
Okay.
Yeah, because this right here, you can't use those ratios anymore.
Yeah.
Yes?
Oh, okay. So, like, when we were doing, like, 15 divided by 17, like, for the first one,
Yep.
and we did 4, like, places after
Yep.
the decimal point, is that what we're always going to do?
Yes, and then on this one, we didn't go 4 decimal places out because it stopped, like it ended. So technically it would be 1.8750 if you really wanted to do, but you don't have to put that extra 0 at the end. Can somebody tell me what that means, 1.875? Which one's bigger? Isn't opposite bigger than the adjacent?
Yes.
It's almost double. Isn't 1.87 almost 2? That's 187%. So 15 is 180% of 8.
So why do
That might not mean a lot right now because I don't even know what angle A is. But for every right triangle, when I'm dealing with either one of these acute angles, based on these sides or the angles, I can find out exactly what percent of the other. What percent are these two compared to each other, these two compared to each other, and those two compared to each other? And that is very helpful when we get applications done. I just want ratios. Sir?
So why would we need one of the, like, more high-grade calculators?
Yeah, we're going to do that this afternoon. We're going to actually use sine, cosine, and tangent buttons that you guys have in your
But
calculators.
if I don't have that, I could just divide, right?
Yeah, here's the application. Ready? Okay, you guys already understand that. Let's say I didn't have this, and I didn't have that, right? All I had was 8, and let's just call that 32 degrees. That's all I had. I would expect you to get me this side and or that side with just these two pieces of info. How in the world can you do it?
8 times 32 divided by 3.
No, but there would be something simple as long as I had sine, cosine, tangent.
So how would you
functions.
put that in if you had it?
Yeah.
I'm not doing. If I go through that, it gets. Well, that's 11-6. Use trigonometric ratios to solve right triangles. So you can find missing sides based on that, but we can't go through that right now, just because I want you to get this down. But we dealt with angle A, didn't we? What if we dealt with angle C, which is what we're going to do? So don't erase it. I'm going to erase it because I need space on my board. Let's do now sine of angle C. Let's look at sine of angle C. All right, so I'm looking at this angle right here. What does sine refer to? Sarah. Sine is what? Just what's that ratio?
Opposite over hypotenuse.
Opposite over hypotenuse. Nick, what's opposite of C? 8. Betsy, what's the hypotenuse?
17.
17. What is that about?
0.4706.
So 1.
Huh.
Sorry.
Looks familiar. Okay, anyway, let's go with the cosine of C.
Whoa.
Let's go with cosine of C. Cosine, Peter, refers to what? What over what? Cosine.
Adjacent over hypotenuse.
Adjacent over hypotenuse. John, what's adjacent of C? 15. is adjacent to C. And what's the hypotenuse, Alyssa?
Oh, 17.
17, which approximately gets me 8, 2, 4. Wow. Huh? Okay, we'll go with that. Look familiar?
Tangent.
How many of you see the familiarity or the similarity or the exactness of some of these numbers? Okay, ready? Here's what it is. Let's see if you can see in your notes. The sine of C is equal to the cosine of A. Is that true? And the cosine of C is equal to the sine of A. But what about tangents? Let's go with tangents
The tangent
of
is equal
C. So what's tangent of C referring to? What two sides, Caroline? Tangent means 1 over what?
Opposite over adjacent.
Opposite over adjacent. Jensen, what's opposite of C?
C, 8.
8. What's adjacent to C, Nick?
Adjacent is a 15.
15. All right, 8 over 15. 8 over
That's
15.
reciprocal.
0.53, which rounds to 0.533.
repeating?
It is 0.53 repeating, but you round it to the nearest 10,000, so you just put 3 3s. 0.53333. And that's your rounded to the next nearest 10,000. What do you notice about tangent of C and tangent of A?
They're reciprocals.
They're reciprocals of one another. Yep. What was tangent of A then? Wasn't it 15 over 8? And that was what, 1.875? That's what we said. What's the reciprocal of 1.875? 0.53333 repeated. This is
Tell us.
no. This is really cool. I want you to memorize Sohcahtoa. If you can do that this morning, you are set. How many of you have already memorized Sohcahtoa? Like, I got it. Okay, looking up without looking at your notes. I want you to say it out loud, but not too loud. We're not going to yell and disrupt it. We're going to say, for example, sine equals opposite over hypotenuse. Okay, and I want you not to drag behind. You know, some people like, go ahead, sine equals opposite hypotenuse. Got it. You see, I'm delaying it because I don't know it. I want you to say it with certainty. What's tangent?
Opposite over adjacent.
Okay, what's cosine?
Hypotenuse.
Adjacent over hypotenuse. All right. Who feels like? I mean, I pretty much got it nailed down. Like, okay, 1, 2, 3. So Peter, Jensen, and Murphy. It's a little competition. I'm gonna call out sine, cosine, tangent, and you say whatever the ratios are, but you can't look at your books. Ready, guys?
Turn it over.
Don't, and no one else interrupt. Cosine.
Adjacent over hypotenuse.
Tangent.
Opposite over adjacent.
Yeah, sorry.
Sine.
Opposite over hypotenuse.
What a legend.
It's in
All right, 3 others. 3 others want to go out here.
Just complete.
No. Yes, Davis 1. Michael 2. Is that it? Yes, Marissa, I saw that hand. 3. Sine.
Opposite over hypotenuse.
You had it first, and I think it kind of so it's opposite over
I
hypotenuse.
can't pronounce hypotenuse fast.
It's okay. I get it.
Did.
That was, no, hypotenuse. Tangent.
Opposite over adjacent.
Opposite over adjacent. 1 1. Sine.
Opposite over hypotenuse.
Cosine.
Adjacent over hypotenuse.
Okay, so Michael. One more. Another 3. Last 3.
They're gonna go to the
Championship round.
No, just is gonna destroy you guys.
No 3? Yep, Sarah, I see that hand.
Let's just
Nick,
all
I
three
saw
go.
that hand.
No.
And John, I see that hand.
Just don't say anything.
Tangent.
Opposite over hypotenuse. Or no,
we
adjacent
started.
over hypotenuse.
Opposite over
I can't
adjacent.
say hypotenuse.
It's opposite over adjacent. So 1.
Cheater.
Sine.
Opposite over hypotenuse.
Yeah.
I think Sarah got that.
I think it's.
Gee,
I got that.
I already have one.
What?
Cosine.
Adjacent over hypotenuse.
Ooh, 1, 1, 1. Next one goes on. Tangent.
Opposite over adjacent.
All right, 1, 2, 3.
You
I know
just
this is
got
a
five.
Yeah, I know.
Well, no, we all had one.
I tried the first one.
We
So
didn't need
I
to
know.
complete class.
Tangent.
Opposite over
Adjacent over
adjacent.
opposite.
Oh, Sarah got that.
Opposite over adjacent, yeah.
Did you say opposite over adjacent? Okay, so that was it.
Jesus, it was adjacent.
Sine.
Opposite over hypotenuse.
Oh, Michael.
Tangent.
Adjacent over
Adjacent.
opposite.
Opposite
Opposite over adjacent.
Jensen.
Opposite.
That was okay.
That was.
That
That was not me.
Just don't count them.
You were ready for cosine, right?
Right?
But I gave you tangent. That didn't count. Cosine.
Opposite over. No, adjacent
No,
over
adjacent over hypotenuse.
Last one here, you win it. If you get it, you can tie it with them if they get it. Tangent.
Opposite over adjacent. Ooh, yes, Sarah.
Tie.
Yes,
Tiebreaker. No, not that one. That one. No. Yeah. Yes. Sine.
Opposite over hypotenuse. Yes, yes, Sarah. Woo.
Opposite over hypotenuse.
Hi, Jason.
Now, I don't want you to raise your hand. Don't raise your hand. But how many of you think you could have beaten that Sarah or the
That was for
No.
short hand. That was for
That was
short hand.
definitely
No
right.
hands,
Jensen definitely will know.
Yeah, Jensen.
homework. Numbers 2 through 8 all.
Sure, hey, do you have a piece of paper? Or I need to buy some.
I went to lunch.
I'll take them.
Man, stop eating meat. Man, stop. Oh no, we have to dot. Oh wow.
Goodbye, Swivel.